All right, and we're back with a little bit about solving complex equations. We're on the third part of this three-part series on solving them. And we're going to kind of go back a little bit and talk about one of the things you took notes on and how it's going to apply to one of the problems we're going to do. So, what I want to really point out is this inverse side of your notes. And again, really emphasizing the highlighted is what you should know off the top of your head. But all of this is something you should be familiar with, at least to the point where you understand what's happening. And again, it's Googleable, so you can look it up. But most math people know the natural log of 1, if they see it as 0, the natural log of e, if you see it as 1. So those are kind of like just reflex things. But on the inverse side, I want to point out a particular piece because it's going to come up in one of the problems I'll show you of what it's really saying. You wrote it, but you may not really know what it's meaning. So, for instance, if I really did write or see on a sheet of paper log 2 base 2 argument of 2 raised to the third power, if I see that, I know that really this piece right here is my clue to know that really the answer is just whatever the exponent is. It's going to be 3. Now, but this also works in reverse, meaning I can actually change something to have the same base and argument and raise it to a power. And in essence, that kind of helps me sometimes solve logarithmic problems by sort of putting in what I need it to be. So let's say, for example, a different number. Let's say I saw 4. Well, if I did log 2 with a 2, I can put to the 4 power, and in essence, these two things mean the same thing. Sorry, that doesn't look good, but those are arrows that are going back and forth. So they actually are saying the same thing. Maybe I should this way. They are saying the same thing. So again, this is going to come back in one of the particular problems that we're about to do in a moment. And having that sort of pre-knowledge will really, really help you. So without further ado, let's go ahead and look at these final 2 hard problems when it comes to solving with logarithmics. So here's our first of the 2. We see that it says natural log of the quantity x plus 2, and then plus the natural log of the quantity 3x minus 2, and that equals 2 natural log of 2x. Now, again, my mathematician mind is sort of, again, because there's a lot of different problems that will run at me, and I'm always trying to think, what is it that I can do to solve for x? What is it that I can do to get me the x? And so I got property rules I can use. I have these inverses. I have a lot of different pieces to this that could possibly be used, but I'm always keeping in mind that in essence, I'm solving for x. And some of the basic common rules is if I have one logarithm on one side and it equals a number, then I can change it to exponential. So that can kind of help me. Or if I happen to have 2 logarithms on either side and they have the same base, then their arguments will be equal. So I'm going to sort of start moving with some of the properties because I can see properties here and see if maybe one of those features will pop out at me so that I can solve. So automatically when I see problems like this, I immediately take my eye and I notice the plus sign and a multiplying piece. Those are very sort of alarming things to me to let me know that I got the quotient, product, or power property happening. Well, the product property says if 2 things are being added, then you can actually take their arguments and multiply them inside the same logarithm. So I'm going to write natural log quantity x plus 2 times the quantity 3x minus 2. That is literally the same thing as those 2 things being added together. And then on the other side, since I see the 2 in front, that's kind of a clue that I can make it into the power rule. So the natural log of 2x squared is what I can do there. And automatically, with me just using those 2 rules, I see with my mind's eye that I got a natural logarithm here. I have a natural logarithm there. Automatically, really, there's a base e down there. And if I have two logarithms on either side that has the base the same, then that means their argument is the same. So I can make x plus 2 times 3x minus 2 equal to 2x squared. Now, technically, I was supposed to distribute so that I really have one complete argument, but you know, if our mathematicians know, okay, technically I distribute that, that's still the same thing. So I'm just kind of skipping one step of distributing early before I make it equal. So I can now distribute, and I have 3x squared minus 2x plus 6x minus 4 equals 2, oh, so sorry, that was supposed to be in parentheses, minus, 4x squared, because the whole thing was squared. That looks a little bad. I'll go ahead and fix it and make that 4. Okay, now I can simplify and bring everything to one side. So 3x squared plus 4x minus 4 equals 4x squared. Now I need technically all of these things on one side, and I really like for the x squared to be positive. So I'm going to move everything to the right side because that will automatically make it positive because 4 minus 3 is 1. If I subtract 3 from 4, it's negative, and then I got to divide out a negative. Just try and keep things in the positive. When I move over, I'll get a 0, nothing on that side, but this will become x squared minus 4x plus 4. Now I can do again my algebra 2 background knowledge and make it into two factors. I have x, and I have a minus 2 and a minus 2 because negative 2 times negative 2 is a positive 4, but negative 2 plus negative 2 gives me 4. Or in essence, I have the same thing. So it's just one thing I have to write to equal 0. So x equals 2. And again, just for sake of time in this video, you should definitely put the 2 back into the original problem and see if you do get the same result on both sides. Okay, now for the next problem. Again, a log problem where I have a base that's the same, some plus signs, and it's equal in number. And just like before, I'm kind of using my mind's eye to see if there's anything I could do that will help me make this work towards my goal of solving for x. So I see immediately the plus sign. So again, I can write log 12x times x minus 1, because those two are the product property, equals 2. All righty, I'm almost there. Just to go ahead and make this complete on the left side, as I was mentioning that I skipped the last time, I'm going to go ahead and write log 12x squared minus 12. That's really my argument altogether. So distribute, but notice I have a log, base 12, an argument equal to. I can convert, as we've done before, but I want to go ahead and show you an inverse property way so that you can have another way to solve just in case the conversion is not as friendly for you. So here's what I mean by that. Right now I have log 12 on the left side and I have a 2 on the right side. That inverse property says if I go ahead and make, again, log, let me write this on this side, log 12x squared minus 12. If I add a log 12, because I need it to be that base, but I also have to have this be 12. Again, remember, I have to make it match. But if I put squared on here, then I really didn't change that 2 from being the answer. But what I did do was make 12x squared minus 12 equal 12 squared. Because if my bases are the same, then my arguments are the same. So 12x squared minus 12 equals 144. And then I can move everything. Oh, I completely forgot to write an x through all of this on the 12. So sorry. Forgot to distribute it. So I move everything over to the left side. So I have 12x squared minus 12x minus 144. I can divide all of this by 12 to make this a little simpler. So when I divide this by 12, I get x squared. When I divide that, I get minus x. And when I divide that, I'll get 12. Okay. And of course, all of this equals, these two equal 0. Not this one. And so now I'm running out of room. Let me go over here. I'll make two factors. So I'll have x and I'll have x. And 12, 4 and 3 makes 12, but 4 minus 3 makes 1. I'll make the negative on the 4 and the positive on the 3. Again, x equals 4 and x equals negative 3. I always check my solutions when I have two different properties, and the negative 3 would not work if I was to go and plug that back in. So I cross it out, and I'm just left with x equals 4. Okay. Please remember to rewind, play again, go over this, meld it over. Notice how I kept using the 3 product quotient and power property the most in solving these equations, and encourage you to go and practice from the problem sets in Shobi, as well as the book problems, and come to the help desk after you've wrestled a little bit to get some help. Good luck.